we are discussing the counters. Okay. Now here you are looking like there are four columns. There are four columns counting from 0 to 0, 1, 2, 3, 4, 5, 6, 7 and so on up to 15. Okay. Now this column, this one, this is these are the least significant bits. Okay. In this table, this is the least significant bit. Then, like in least significant bit, like is toggling. Toggling means changing the state. 0 to 1, 1 to 0, 1, 0, 1. It is toggling like one state to second. It is toggling at every bit. 0 to 1, then again 0, like that. This is then this least significant, this is the most significant, then still more significant, more and more significant bit, this column. Or you say this is the least significant and last one is the most significant. Now least significant to next one, which is where like 2 zeros and 2 1, 2 zeros and 2 1. They are toggling. Okay, but it is toggling half the rate of the previous one, because 2 zeros then 2 1, 2 zeros then 2 1. So they toggle half the rate of the previous one. Now in this column you are looking like there are 4 zeros, 4 1, 4 zeros, 4 1. Again they are toggling half the rate of the previous one. And last one, which is the most significant, 8 zeros and 8 1, they are again toggling half the rate of the previous one. This is like the logic here. There's a counting from. Okay, and this is the toggling at every bit, then toggling half the rate of previous one, again the half the rate of previous one, again the half of the rate of the previous one. So there are the three flip-flops. JK flip-flops 1, JK flip-flop 2nd, JK flip-flop 3rd. And JK of all the flip-flops are connected together and given a high to all the flip-flops. They are connected together and given a high, mean 1. And as the JK are connected together, they serve as here the toggle flip-flop. They start toggling, they will toggle when they meet a clock pulse. Okay. Now then, as a clock pulse, it is not applied simultaneously to all the flip-flop. The same clock is not applied simultaneously to all the flip-flop. That's why the name is asynchronous counter. Asynchronous means we call it asynchronous because they do not have the same clock. Okay. The output of the first flip-flop, which is Q0, becomes the clock of the second one. And the output of the second Q1 becomes the clock of the third flip-flop. Right. Now this is a clock pulse, which is you are looking here. And the falling edge, because here is a triangle and a circle, so that means the falling edge is effective. So when the falling edge arrives, what happens? The first flip-flops toggles. So toggles mean it goes from low to the high state. Okay. And when the next falling edge arrives, it again toggles, it goes from high to the low state. When again the falling edge arrives, it goes from low to high level. And again when the falling edge arrives, it goes from high to the low level, and it repeats on. Okay, now this is the output of the first flip-flop, that is Q0. Now Q0 becomes the clock of the second one. The second will toggle with this clock pulse. So when the falling edge, this edge, arrives to the second flip-flop, this flip-flop will toggle. It goes to low to high level. Okay, when again the falling edge of the clock pulse, which is to the second flip-flop, and the second flip-flop again toggles high to the low level, and it repeats on. So this is Q1, which is the output of the second flip-flop. Now we are coming to the third one. Now the output of the second flip-flop, now it becomes the clock of the third flip-flop. Now this is the clock of the third flip-flop, and this is a falling edge. Now it is effective, and third flip-flop will toggle when this falling edge arrives. It goes from low to the high level like that. And again there is a falling edge, again it goes from high to the low level. So this what is happening. So okay, now looking here, this is 0, this is 0, this is 0. So 0, 0 and 0. This is first count. This is 1, which is the least significant bit. 1, 0, 0. Okay. This is second count. Then 0, 1, 0. Third count. 1, 1, 0. Next count. Then here 0, 0, 1. Next count. 1, 0, 1. Next count. 0, 1, 1. Next count. 1, 1 and 1. This is now the counting is there. There's an up counter, and it is a synchronous. Sorry, not synchronous, I'm sorry. This is asynchronous, because the same clock is not applied to all the flip-flops. So this is a very simple working. The first flip-flop will toggle with this clock. So this is the output of the first. Now second flip-flop will toggle with this clock. This is the output. And third flip-flop will toggle with this clock, and this is the output. Okay. So here it is 4-bit synchronous counter. This is called synchronous because the same clock is applied. Same clock means like this is a clock. Same clock is applied to flip-flop number 1, to the second, to the third, and to the fourth. And there are 4 flip-flops, that's why it's a 4-bit. Same clock means synchronous counter. So this is the output of the first flip-flop Q0, and second Q1, third Q2, fourth one is Q3. So Q0, Q1, Q2, Q3. Okay, J, K are connected together, looking like all the flip-flops J and K are connected together. That means they will behave like a toggled flip-flop. They act as the toggle. Okay, they will toggle when they meet the clock. Before discussing that how they count, let's see what happen if we give this type of the clock pulse. If we give this type of the clock pulse to the first flip-flop, now first flip-flop starts toggling because the flip-flop is a triangle, not a bubble. That means the leading edge, it is the effective. So when the leading edge comes, it starts is toggle from low to high state. Again, rising edge, high to low. Again, rising, low to high. Again, rising, high to low. So it's toggling. Now Q1 is also toggling with the same clock. Like the same is there. Q2 is also toggling with the same clock. And Q3 is also toggling with the same clock. Now this is not the counter because Q0, Q1, Q2, Q3, they're all having the same value. Like 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. So that's not counting. But it's just to understand, if we give the same clock and J, K are connected together, If we give a clock pulse, so what happens to Q0, Q1, Q2, Q3? They will attain the same level at each time when the rising edge of the clock comes. Okay. Now let's looking about that. Actually, what's the logic behind the counting? So this is 4-bit columns for counting, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. Now you're looking here, this looking like the first one. It toggles 0 to 1, 0 to 1, 0 to 1. Every time at each bit it toggles like 0, 1, 0, 1, 0, 1, like that. Now look the second one, 2 zeros to 1, 2 zeros to 1. But it toggles, when the in the first column, when this is high, this 1 is high, it toggles 0 to 1. Again, when this 1 is high, this 1 comes, okay, in the first column of the 1 comes, it toggles 1 to 0. Again, when this 1 comes, it toggles from 0 to 1. When this again 1 comes, it toggles 1 to 0. Again, when 1 comes, again there's this, when 1 comes, toggles 0 to 1. And again this 1 comes, toggle 1 to 0. Again when the 1 comes, toggle 0 to 1. Again when the 1 comes, and so on. Now looking to the next one, when there are the 4 zeros and 4 1, like when 1 and 1 both are 1, then third toggles 0 to 1 state. Okay, when the both first column 1, the second column of this bit is 1, then only toggles 0 to 1. Again looking like when 1 and 1 is here, then only toggles the third one 1 to 0. Again when 1 and 1 is here, then it toggles from 0 to 1. This you understand. When both these columns are 1, then it toggles. Okay. Now coming the last one, 8 zeros and 8 1. Now looking when all the three are 1, 1, 1, 1, only then it toggles 0 to 1 state. And when all 1, 1, 1, then it toggles 1 to 0 state. So this is the logic behind the, counting up counters. Okay, now let's looking about the circuits. So this is the circuit. Flip-flop number 1, second, third, 4. The same clock is pulses applied to all the flip-flops, number 1. Number 2, J, K are connected together of all the flip-flops, mean they will act as they will now perform the toggling event. Now then, here, look, this flip-flop toggle for every, when the clock pulse comes, this starts toggling. So first of all, Q0, it toggles for every clock, and the rising edge of the clock, it will toggle. Like Q0 toggles, this comes, it toggles. There's some delay, okay. Then the rising edge comes, toggles 1 to 0. Then rising edge comes, toggle 0 to 1, and so on. So this is what's happening at the output of the first. Now coming to the second. Now for the second, the Q0, this Q0 is the connected to G and K. Together they are connected, as well as they are connected to Q0. That means this flip-flop will toggle, number 1, when the clock is high, when the rising edge of the clock. Second, when Q0 is also high. So this will toggle if Q0 is high, because Q0 is applied here to J and K together. Now looking here. So this will toggle, this is high, and the rising edge is there, 1 is there, then this will toggle Q1. Okay, now coming next. This is high, rising edge, the 1, so it's toggle 1 to 0. then coming next. There's this rising edge, then this is high, so it will toggle 0 to 1. So this is the output of Q1. Now Q1 is given to AND gate. Q0 is also given to AND gate. Okay, Q0 and Q1, the AND operation is applied to the third flip-flop. The third flip-flop will toggle with the rising edge of the clock and when Q0 and Q both are high. Okay, so this flip-flop toggle if Q0 and Q1 both are high. So let's looking here. So the third one it will toggle this rising edge, this is high, so this toggle 0 to 1. Now coming next, this is rising edge, this is high, so it will toggle high to low. Okay, now next coming the output of now next one, this output is applied here and output of the third flip-flop Q2 also applied to the AND gate, and that is given to the JK of the fourth flip-flop, and fourth one will toggle with the rising edge of the clock and when here there is Q0 and Q1, here is Q2, when Q0, Q1 and Q2 all are high. Now looking here, so when it will toggle when all are high, rising edge, this is high, then it toggles 0 to 1. Now let's look about the counting. So this is 0, 0, 0, 0. Here 1, 0, 1, 0. 1 is the least significant bit. 1, 0, 0, 0. Here 0, 1, 0, 0. Next count 1, 1, 0, 0. Next count 0, 0, 1, 0. Next count 1, 0, 1, 0. Next count 0, 1, 1, 0. Next count 1, 1, 1, 0. Like that. This is how the counting. Last one is 0, 0, 0, and last one is the 1. So this is how the counting it proceeds for the up counter. Okay. Now let's see about how it is about like the now we are looking about the down counter. Okay, how the down counter works. Now let's counting for the down counter. We're starting from the reverse order. This highest value that has 15, you see. This highest value 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. So this is 8. Okay, 8 plus 4 okay is 12. 12 plus 2 14. 14 plus 1 15. So this value is 15. The 0 to 15, that is total 16 counts. So this one is 15, 14, 13, 12, 11, and 10, and so on. Okay, so this is our 4-bit synchronous down counter. This is synchronous because same clock is applied to all the flip-flops. Right? Now JK are connected together high. So JK is high in all the cases. Now one thing is there, like here, we are taking the output of the first Q complement as the given to J and K together, like Q complement, Q not complement is applied to the second flip-flop, and then the Q1 is given to AND gate, Q0 is given to AND gate, the output of that is applied to the JK of the third flip-flop. Then again, the output of this AND gate and Q2 complement is applied to the AND gate and output of the AND gate is applied to the JK of the third flip-flop. Now one thing is important here, like this is toggling 1 0 1 0 1 0 1 0 like that. Now second column toggles when here the 0 comes, it toggles 1 to 0. 0 comes, it toggles 0 to 1. 0 comes, it toggles 1 to 0. 0 comes, it toggles 0 to 1 like that. Now next, this one. Okay, this one, like here, there are 4 zeros and 4 1. So it toggles when both are 0 and 0, then it toggles, 1 to 0. Again, 0 and 0 is here, it toggles 0 to 1. So when both 2's are zeros, then third column toggles 0 to 1. Now coming to the fourth one. The fourth one toggles when all 3's are 0. 1, 2, 3. It toggles 1 to 0 state. Again here it will toggle 0 to 1 because all 3 are zeros. So first we'll toggle at every clock pulse. Then Q naught complement becomes the given to the JK. So this will toggle, when Q naught will be low. When Q naught low, then Q naught complement will be high. When Q naught complement is high, JK high, it will toggle with the clock. And remember, then Q naught is low. Likewise here, when Q1 is low, Q1 complement will be high. When Q1 complement high, as well as Q naught complement high mean Q naught low and Q1 low. Then the output of the AND gate will be high, so this will high, and then this flip-flop will toggle. Okay, this will toggle. Now then, the output of this is given to AND gate. If Q2 is low, Q2 complement will be high, and if this is high, this high mean Q1 low and Q0 low, then this will toggle because Q0 is low and Q2 complement is high. Then high, then okay, again you got the same output at here, last one. So this is the logic behind the how we count in case of 4-bit synchronous down counter. Now we are going to up and down counter together. Up and down counters. Now down counter toggling is just 1 0 1 0 first. This will toggle when the 0 is there, toggles 1 to 0. 0 is there, toggle 0 to 1. 0 is there, toggle 1 to 0. Like that here. Okay, 2 zeros are there, toggle 1 to 0. 2 zeros are there, toggle 0 to 1. Like that. So when all the 3 zeros, toggle 1 to 0. This is the logic in case of down counter. In case of up counter, first toggling. Second, when 1 comes, 1 is there, toggle 0 to 1. 1 is there, toggle 1 to 0. When both 1 are there, toggles 0 to 1. When both 1 are there, toggles 1 to 0. When all the 3's are 1, toggle 0 to 1. So now this is the logic for down and up. Now here this is a circuit. Okay, so this is a line, this line, because it works for up and down counter together. For up, here it is 1. For down, here it is 0. So for up, here it is 1 mean this, the upper system will work. For down, here it is 0. 0 mean the upper system is ineffective, but lower system 0 to becomes 1. Lower AND gate becomes effective. So now coming for the up counters, the upper system is effective. Upper system is effective. So how the case is, how the case is, like this is here given a 1. So 1 is here, okay, 1 is here. Now it depends up output will depend upon Q naught. If Q naught is also 1, if Q naught is high, this will be high. But at the same time, here it is low. Low output of this AND gate is low. Output of this AND gate is low. Output of this AND gate is low. The lower system is ineffective. So this one will pass if the Q naught is high, and will pass through the OR gate also, and will be applied to J key. So if Q1 is high, and this is also high. If this is high, given to AND gate will give high. That high will pass to the OR gate and apply it to the JK. So this is the upper system, how it is effective, and the counter act as the up counter. Okay, when like the down, this is 0 is here, the output is 0 is here, output is 0 is here. So upper system is ineffective. But low, this is 1. Okay, this is 1. When Q naught complement is 1, mean when Q naught is low, this Q naught complement will be 1, this will be 1, 1 passes through it, and JK applied to JK. Like that, when Q1 is low, Q1 complement will be high, this is also high, it passes the AND gate, passes the OR gate, that becomes the high to the this flip-flop. So, and it so on. Now this is how it works, the down counter. That means here if this line is 0, this will act as the down counter. So lastly, this is timing diagrams for up and down. Okay, up and down counters. So first of all, this is counting, up counting, 0, 1, 2, 3, 4, 5, 6, 7, 8. Then 8, 7, 6, 5, 4, 3, and so on. Now then here you are looking clock pulse, rising edge, is effective. This is up and down line. The line is up for some counts, then we enable it to, we give it down. Okay, the line is up for certain counts, then it made down for certain other counts. So up for from here to here, then down for onward. Now what happened, the Q naught, it toggles for every the rising edge of the clock, like this toggle, like 0, 1, 0, 1, so on. Now the second one will toggle if it meets the rising edge as well as this as high. So clock as high. So clock is high here, this is 1 here, so toggles like this. Now this is 1 here, rising edge here, toggles 1 to 0. There is certain delay also. Now this is 1 here, rising edge here, toggles. Now then rising edge here, and 1 is here, toggles. So like that again. This is a rising edge, and 1 is here, toggles. So like the toggling. Q naught toggles. Okay, Q naught toggles when the rising edge and Q1 and Q2, Q naught and Q1, both are high. Looking here, 1 is here, 1 is here, 1 and 1, clock is here, clock 1, 1. So this actually, this is high. This one is high, clock is here, there's certain delay. So this also high, so it toggles. So this is again a clock is here, certain delay is there. Then it is 1, this also 1, the 1 and 1 with clock toggles like that. 1 is here and a clock toggles. Okay, clock is here, 1 is here, 1 is here, toggles. So this toggle when, like here, what happened, this will toggle when this is high, this is high, this high, this high, this high, with the clock. All the three are high, toggles 0 to 1. Okay, all the three are high, this one, this one, this one, toggles 1 to 0. So keeping in mind that here it is going from high to low. So this is what is happening. Now this is 1 0 0 0, 0 1 0 0, 1 1 0 0. So this all the counting is here. This all the counting is here. This counting is here. This is up counting, then this is down counting. So from up to these values, they will act as a down counter. Like this is in repetition, 0 0 0 1. Again 0 0 0 1. That's the same state. But after that it is a repetition. That's the same state. Then this value and this value, they are the same. This value, and this value, they are the same. So this is how this counter acts at up and down. For some counting, this line is made high. For other counting, the down line is made high. So to get the all the counts, up counts and down counts together. Okay, thank you. Hello my dear friends, please subscribe my channel and do not forget to click on a bell icon to get the notifications about my new work. Thank you very much.